Okay, I'm Fred Azinger and this is Gabe Kenville. We're Team Hardtail. We're from Portland, Oregon, and this is our rocket hardtail. It's 12.5 inches or 12.5 feet tall, 7.5 inches in diameter. This will be its third flight at Balls. We flew twice last year. Today we're flying on a Alumaflame Blue N4500, and then after a 4-second delay after MECO, we'll air start 3 red L1200, 54 millimeters. So we're shooting for about 15,000 feet. And we're throwing all the laundry out up top because we've got 2 video cameras on it. We want maximum hang time, the best footage out of the video. Video arm is lower set, which is video. So it's probably over here, of course. Come down, down, down. Right there. Mikey, are you ready? Here, gentlemen.
My name is Dan Strudd, and this is my buddy Pat Gordslip here. This is Zeus, ruler of the sky. And we have an N3000 in it. So it's going to go about 25,000 feet, maybe not too high, but it should be fairly quick. So we'll see. Good little first flight of the day. Going to give us a little idea what to expect today.
Do you have reasonable assurance you're not going to kill our pad? Because we got about 8 projects going on.
Oh, yeah.
Yeah.
Yeah, this is a tested motor.
Okay.
Hi, I'm Wedge Oldham. We're from Los Angeles, California, and I'm here at the Black Rock Desert to fly my Black Brant project. This is a 107% upscale of the real Canadian Black Brant 2 rocket. This rocket stands 30 feet high, 18 inches in diameter, weighs 700 pounds on the pad, and is powered by a cluster of 3 P motors. The total impulse of this rocket will be in the Q region. For recovery, I've got a 27-foot drogue parachute that's going to pull out a 46.5-foot main parachute. Estimated altitude, best case is 20,000 feet, worst case is 15,000 feet. The rocket should go Mach or very close to Mach, and it's taken about 2 years of construction time, including the design, and the actual physical construction started roughly around March when I picked up 3 10-foot sections of tubing and started cutting them up. The people you see behind me here are doing the final prep on the rocket. We're joining the 2 sections. We're getting ready to carry it out to the pad. This is definitely the biggest rocket that I've ever done, and it's quite the harrowing experience. The one major stumbling point that we're all concerned about is the 60-foot launch tower that's positioned a half-mile out there. Lifting 400 pounds of rocket empty and positioning it on the launch tower is really going to be a difficult task. It's going to require quite the coordinated effort amongst a lot of people, and we have to be careful not to drop it. That's about it. We had originally scheduled to go at 9 o'clock. We're running a little bit late, but we're not going to be running too much late behind that. So this could definitely be one of the more spectacular flights. Another interesting aspect, we were concerned about the 3 P motors hitting the blast deflector of the mobile launch tower. So what we did is we removed the blast deflector. We bought a $5 kiddie pool, 5 foot in diameter, and 110 gallons of water. We're going to fill the kiddie pool with water, place it directly underneath the rocket, and have it act as a deluge pond. This shall also increase the dramaticness of the liftoff, because all 3 of the P motors are going to be striking that water, flashing it to steam, and could make a tremendous cloud upon liftoff.
I'm seriously thinking I need 11 on each side. The rocket's going to weigh about 400 pounds. Probably is 400 pounds. 11 people on the side makes it 20 pounds a hand, or 10 pounds a hand.
Body. If we don't have enough here, some of us, if they can come down here, some of us can run up there.
Ranger, come here.
Yeah, we're fine.
Okay, let's work together, gentlemen, all right?
Watch the trailer, guys. Squats. Done talking.
Up.
You need to go
Higher. Up.
Not too much pressure on the nose cone.
Okay, we're going to have to rotate just a hair.
Paul is running away from it as fast as an old guy can run.
Hold it. Get your hands up there. Okay, here comes the first one. Needs to come down.
Okay, people that are falling off the back, please move to the front.
Okay, we're ready to try this one. We're going to try this again. And we'll go in 5, 4, 3, 2, 1.
Slow and easy, gentlemen. Slow and easy.
Slow. Easy, right below it, Jason.
We got it. Okay, keep going, gentlemen. The fin needs to catch. We'll be supported underneath this wood here. Okay. So bring the rocket forward. Try and support it. Keep the weight off the rail guides. Need people in the front.
Okay, there we go. There. Now, but the wood's not further away. How much further? Socks. That's it.
There's a piece of blue tape on the rail.
Oh, a little more than that. 3 inches further. Keep going. 3 inches. There you go.
But the
Okay.
support side lining up.
Right there? That's close enough, isn't it?
Ranger. How much twist you don't Come on, let's go.
Okay, let's try and see if we can find some towels or blankets and take up the slack between the fin support and the fin. Carpeting, guy. Okay, so I guessed wrong. Jesus, give me a break.
Let go. You can let go.
Should be stable. Should.
Ow!
Nice. The aft motor support is there with 4 1/4 20 screws. It slides onto this rail and butts up against the aft end. We got to get the jacking gear off first. It'll be a 7/16. Save the bolts and washers. They form the retention. We're good for now.
Socket set?
We're going to wait until we get the aft support, then we can push against it.
You're going to need muscle getting it up?
I doubt it, but it is a possibility, but it won't be a critical thing. The rocket will be supported, so we'll be good there.
I'm going to go man my camera.
We're definitely going to, yeah, we're going to need some help with each individual motor. No, what it is, it's a shunt. So.
Oh, okay, good. We're in good shape. Good.
Yo! No, I am not.
Okay.
No, I got a blocking bridge rectifier in there. I'll accept anything. Victor, can you handle drilling and tapping and sure pinning the nose cone?
Yes.
All right. You'll commence doing that as soon as we... Okay, as soon as we get
Show me what you want me to do. How many and
all right.
What any type of pattern that you prefer or no?
We'll get Steve Trammell to help you out too. Steve Trammell, are you around? Okay. I'd like you and Victor to work together in the future on shear pinning this nose cone. Oh, yeah. Basically, arbitrarily pick out 3 points. Somewhere, you got to hit an area 18 inches. Anywhere in there, it'd be kind of nice if they're all in the line. So like that button, back to the nose. Drill it through, tap it.
How far back? I think it's a pure miracle to handle drilling and tapping.
All right. That's doing that as soon as we...
100 feet of wire attached to an extension. Okay.
That's a little better.
When it comes time to insert the igniters, we are all clearing this area.
Oh my freaking God. It looks serious.
Boy, it sure got bigger, didn't it? Wow.
Low.
Stop. We're good. Secure the guy wires?
Yes!
Yeah.
Woo!
Yeah, I'm going up after that next.
project from Raytown, Missouri. This is called Stella. It's got a P15000 in it, 79,000 Newton second motor. Projected altitude, we don't know, 45 to 60,000 feet, somewhere in there. And hopefully it's going to work. This is the third rocket we've done like this. All aluminum from the tip to the toe, more or less. And it's got an Altec in it. Hopefully it works. Otherwise we got video of it. Send back to Scott. So that's really about it. I mean, it's just a beast.
Name's Ron Weigel from Salt Lake City. The project is called More Bad Wiring. Team members are myself, Jerry Hughes, and Jack Blair. The rocket is 14 inches in diameter, 20 feet tall. It's flying on an O and 4 M's. The O and 2 of the M's are starting on the pad, and then we're going to air start at 6 seconds, 2 of the other M's. It breaks apart in apogee into 2 parts. Each part has a drogue, and then each part has altimeters and dual deploys. There's a 33-foot military pilot chute on the lower section, and a sky angle chute on the upper section for the mains. Sponsors are Woody's Pro X Hardware, Olson Advanced Electronics, and Rocky Mountain Rocketry.
Great. I didn't know that was you. I didn't know that was Woody.
1.
Les Durkovitz, Pioche, Nevada. That's north of Vegas. This is another Svensk. I'm hung up on this whole Svensk thing, so that's the reason for the colors, and it's a Swedish Dirigen thing. It's fiberglass and carbon fiber fin can that Jason Gimbel made up for me because I learned last year I couldn't make my own work, so hoping for the better on this. And the upper stuff is all Dynacom style airframe. And the motor's an 06000. It's about an 80% O, 32,500 Newton seconds, I guess. And it should burn for about 5.5 seconds. It's our NASA blue.
Irritate me too sometimes when they do that. I take the styrene rod and I put a little bend in it before I stick it in, and it torques it. I squeeze them with a Yep, deform them a little bit. Yep.
Okay, I should do that. Okay, I'm ready to turn it on, so. Okay, the gee whiz is there. And the arts is there.
I'm Jason Bladsheim from Winnemucca, Nevada, and me and Dave Potter over here are flying this rocket. It's a Dynacom 5-inch Anaconda, right? It's Anaconda? Yeah. Loaded with an 6800 Everclear motor. It's good for about 23,000 Newton seconds. The airframe's been flown before about 7 or 8 years ago. This motor has not been flown before, so we're looking to see what happens today.
Hold on.
I'm Kimberly Harms, the team leader of the Community Space Program, which is the group that's doing this project. It's, as you can see, a full-scale Honest John firing 4 O motors, which totals out to about 86% of a cube. Lots of people on the project. You can get a shot of the fin. It has everybody's name, and I'm not going to try to read all right now. There's a lot of people. You know, it's going to go up. It's going to break into at apogee. We're going to put out 3 chutes. 1 on the nose section and 2 on the main section, and something will happen.
Okay, lift it up. Keep lifting, go slow. You're not pulling yet, Christopher. Keep pulling, keep pulling, keep pulling, keep lifting, keep lifting. Right there. Keep lifting. Right there. Whoa. Oh! You guys got horsepower,
This is beyond lift right here. Yeah, we won't be able to push this.
Let's come back. You're going to be.
Oh, okay. You guys bring it back down a little bit.
It's going to be closer to right here.
Oh,
right
maybe
there.
here. Yeah.
Okay, that's your mark right there.
And that's right at 45. I think that's why I think we're going to need a vehicle. We're going to need a vehicle on that thing.
They're not going to be strong enough to
pull
that.
They're not.
I'm going to retie you.
Just stay upwind of the vehicle at this point.
Good enough. Just slack up a little bit. It's flat and it's crosswind, Tom. Scott, we've got a lot of people.
Okay, this is the Precision 1 rocket. It's the first liquid oxygen hybrid to be flown at Balls. We've been working on it for about a year now. And it's a P6000 rocket motor, 45 pounds of liquid oxygen and 16 pounds of HTPV. And Frank will talk about the payload.
Okay, the basic construction is an aluminum 6-inch outside diameter aluminum. The payload compartment is comprised of onboard computer at MCC102 with X-time timer. It also has an onboard camera, and it has a black sky recovery dual deployment parachute system. Anything else in there that we want to talk about? And it has the GPS flight systems as well for tracking. We'll be tracking it also with directional antennas with the use of 2 rocket hunters transmitters. So that should be good.
There's a shot for you. Alright, I'm coming down. Oh, I do need that white. Route it. Erecting the flag. Did I ever tell you how much I hate heights? You know, I can't dive off a high dive.
I'm Mark Brown from Lee Summit, Missouri. This is my fourth Balls. This year I've got a rocket called Recipe for Disaster, and it's going to fly on a P7000, a red flame, kind of a Polish Roho derivative motor. If it works, should get to about 18,000 feet. We'll just have to wait and see how it goes.
If it don't work, it'll go 8 feet.
Yeah. So, having a few little issues getting the sections together, but I think we pulled some tape off. I think it'll go here in a minute.
Where is it? It's going right now. Big one out. No altitude.
Hi, I'm Dave Leininger, Tripoli Prefect, Minnesota, number 45. This is our project, Big Yeller. It's actually started out with Brian Elfert. He had Old Yeller, which you might have seen in extreme rocketry, crashed. So this is kind of a dedication to Old Yeller right here. It's an 11.5-inch diameter rocket. It's got an 3000 experimental motor in it, dual deployment. Weighs about 120 pounds with the motor in it. So we're hoping for about 10 to 12,000 feet.